Hello, friends, students, teachers, guests. So happy to have you joining us today. My name is Heidi Siwak. I'm your teacher coach for the AI Challenge, here to support you in all the work that you're doing. And welcome to the AI for Good Lab sitemap with Mira Patel. Excited about today's topic. As always, we're going to begin with the land acknowledgement. Let's take a moment to take a breath, a little pause in your day, maybe put your feet on the ground, calming breath. Think about a piece of land that maybe you feel connected to as we read the land acknowledgement. We acknowledge that we are being hosted on distinct and diverse traditional territories of the First Nations and Métis where we live. And I think we are on lands that are governed by the dish with one spoon, Wampum Belt Covenant. The idea is that we all can peacefully live together in sharing this one dish, this land, and all that it provides, so long as we are each mindful of only taking what we need. We also recognize the enduring presence of all First Nations, Métis, and the Inuit peoples. And at I Think, we believe that the land acknowledgement is a moment for learning. So I would like to share something with you that I've learned as I've been doing my research into artificial intelligence from the Assembly of First Nations, the organization that brings different First Nations groups together, about how they are supporting First Nations initiatives in the face of climate change and as caretakers of Mother Earth. So, as the original stewards of our lands and waters, First Nations are uniquely positioned to lead efforts to protect, conserve, and sustainably manage the environment and its resources. And the Assembly of First Nations has been participating in international climate negotiations for several years now, working on ways to protect biological diversity. First Nations is actually leading the way toward realizing Canada's ambitious nature agenda of Canada wanting to protect 25% of lands and waters by 2025 and 30% by 2030 through the establishment of Indigenous Protected and Conserved Areas, IPCAs, and a Guardians program. So we're intentional, where Indigenous people are working to protect the land using their Indigenous knowledge systems on behalf of all of us as Canadians. And what a lovely thing that is. All right, our topic today. Why should we learn about AI for Good and sitemap.ai? I just realized I'm missing the word about. The AI, as we think about the artificial intelligence challenge and your goal of answering the question, how might AI enrich the lives and possibilities for every student in our school? We want you focusing on AI doing something for good and what are the possibilities there. And the AI for Good Lab is an amazing organization. That's the name of it. And they're doing really interesting work in thinking about problems in the world and bringing a group of people together to work on those problems. And Sitemap is one of the projects that has come out of the AI for Good Lab. So you're going to have an opportunity today to meet with somebody who's working on AI for Good. So with that, I invite our guest today, Mira Patel, to Mira, turn on your camera. Welcome.
Hello, everyone.
Hey, so great to have you here. Mira is in Edmonton today, coming to us all the way from Edmonton. She had to get up early for this. There's a time difference there. Mira is an undergraduate student, so university student at the University of Alberta, who was part of an AR for Good Lab in 2024. And her team worked to build a project that uses machine learning, a form of artificial intelligence, to help visually impaired individuals with navigation. Really an incredible project. I'm so excited to have Mira with us today, who's going to share what an AI for Good Lab is and what her project is. So welcome, Mira.
Thank you so much, Heidi, for the introduction.
I'm going to stop sharing my screen and turn it over to you and turn off my camera and enjoy your time with us today.
Thank you. Let me get my screen shared. Okay. So hi, everyone. I'm so excited to be here today and to be talking to you about machine learning. My name is Mira, and I'm pursuing a computing science specialization in software practice from the University of Alberta. which is one of the world's leading institutions in artificial intelligence and machine learning research. So if any of you are considering a career in AI, computing science, engineering, mathematics, and want to explore Western Canada while you're at it, I would highly recommend you to check out some of our distinguished programs, as the university is at the forefront of groundbreaking scientific research. Our strong research community extends beyond the university, with Edmonton being home to the Alberta Machine Intelligence Institute, which is one of Canada's top machine learning research centers that drives innovation and industry applications. So the project that I'll be sharing today was something that I worked on at the AI4GoodLab, and I was in the Edmonton cohort. So I was hosted by the Alberta Machine Intelligence Institute, so AMI, right here in Edmonton for it. This lab empowered me to work in a team of students to build projects intended to create benefits to our communities with an aim to create social good. So I'll share a quick introduction to the project now. So our project is Sitemap. It's a comprehensive AI assistant to aid visually impaired individuals while they're navigating their surroundings. So in this section, I'll cover the main objective behind why we made this our project, our goals, and our processes. So the main purpose of this project is to enhance the mobility and independence of visually impaired individuals by developing low-cost, user-friendly navigation. And navigation is a critical aspect of daily life for visually impaired individuals. So efficient navigation tools will not only enhance their safety, but it also promotes independence and confidence. By providing them with the ability to accurately understand their surroundings, these tools can help them navigate various environments, such as urban areas, public transportation, areas that are unfamiliar to them. And this will result in a reduction of anxiety while fostering social inclusion. So think about computer vision models like the human brain learning to recognize things that by looking at pictures. Just like you and I can tell the difference between a cat and a dog by noticing their shapes, colors, features, a computer vision model learns to do the same, but with math and patterns instead of eyes. Computers don't see pictures like us. Instead of images, they see these tiny dots that are called pixels, and each pixel has numbers that tell the computer what color it is. To teach a computer to recognize things, we show them thousands and millions of pictures with labels. So pictures will be labeled cat, dog. And then after the model looks at these pictures, it will figure out what exactly makes this image a cat, what makes this image a dog, what makes a cat, what makes a dog. Maybe cats have unique identifying characteristics like pointy ears, and cats have longer snouts. And the computers will learn by adjusting their numbers in ways that help us make guesses and predictions correctly. Once it learns, we show it a new picture that isn't labeled, and we make it try and guess, what is this image? Can you tell me if this is a cat or a dog? And if your model is trained well, it will make the correct predictions. Some examples of computer vision in real life includes using your face to unlock your phones, or self-driving cars that recognize stop signs, or apps that translate text from images. All of these are examples of computer vision. And similarly, computer vision provides an opportunity for innovation to solve our goal. It's a technology that uses AI algorithms to interpret visual data from cameras and sensors, enabling systems to recognize objects, obstacles, and pathways. And these systems provide real-time feedback to visually impaired users to help them navigate safely, detect nearby objects or hazards, and offer auditory or tactile guidance to aid in direction and movement. So why does this project matter? What's so important about it? Let's put it into perspective. So over 250 million people around the world have some form of visual impairment. So that's millions of people who have daily challenges getting around independently. For anyone, being able to move around is a huge part of life. And whether it's going to school, going to work, running errands, independence is so important. And so, but for people with visual impairments, that independence can be limited by the tools that are available to them. And that's where the problem lies. Many current assistive technologies are either way too expensive or just not accessible to the people who need them the most. And that's where our project comes in. So by using affordable AI-powered technology, we can create solutions that actually help people navigate safely and independently. And the impact is more freedom, more confidence, and a better quality of life. Let's dive a little bit into the development process and how our team actually built this project and brought it to life. To get started, we spoke to a Smart Life head coach and public education coordinator at the Canadian National Institute for the Blind to gain a better understanding of some of the greatest challenges with assistive technologies today. The questions we asked them were, what are some of the most useful technologies used by your group's audience? What are some of their greatest drawbacks? When it comes to using technology and apps for navigational purposes, what's important? What's most important for your group to consider? What are the greatest challenges to accessing such tools and resources? What is most important for orientation and mobility experts for training and educational purposes? Is there any sort of technological solution you believe could make a great difference? What are some of the greatest challenges for visually impaired users who are not completely blind? This was a really important step in our development process because when you, like for everyone on our team, none of us had visual impairments. So in order to try and make that social good, identifying a gap is like the first step, but after that, you have to connect with the individuals who face this on a daily basis, people who are supporting them to actually hear what the real problem is, not just what we think the problem is. And I think that's a very valuable first step to making meaningful change in society. And that's exactly where we started off with this project. So when designing our project, one of the biggest things to figure out was who really are we designing for? Since visual impairment isn't just one thing, it's a spectrum. Some people have low vision, some are completely blind, and everyone experiences things differently. So we had to make our design that works for a wide range of users. And so who exactly are our users? First, people with partial or complete vision loss. Some might still see shapes or colors, while others rely entirely on sound or touch to navigate the world. This means we have to make sure our design works, whether someone can see a little bit or not at all. Second, not everyone is a tech expert. Some users are super comfortable with technology, while others might need something that's really simple and easy to use. So we have to make sure our design works for both. And finally, many of our users depend on things like audio cues or vibrations to get around. Think about how you use Google Maps with voice directions. Our design needs to include some features like that. So by focusing on these different needs, we could actually build something that's useful and accessible by everyone. Next, we had to think beyond just making something that works. We have to think about real life scenarios, about like what type of situation is someone going to use this in? And that meant we had to also focus on three more things. Firstly, we need real-time responses because imagine you're using Google Maps and you're trying to get somewhere, and then it tells you to take a turn after you miss your street. For someone relying on this design to navigate freely, a delay like that is just going to be super annoying and counterintuitive. So, and more than that, it can be dangerous. So we want to make sure our system responds instantly. Secondly, it had to be non-intrusive because people already use canes, guide dogs, or smartphones to get around. So our design shouldn't interfere with the technologies that our users are already comfortable dealing with and using on a daily basis. It has to fit right into what they're already using. And finally, is affordability. If a solution is too expensive, the people who need it the most won't be able to use it. So we had to focus on keeping our costs low so people could actually benefit from it. And by keeping these three things in mind, we created something that's actually practical for real world use. Here's a little quote upon discussing with the public education coordinator at the Canadian National Institute for the Blind that really points out and highlights the fact that cost and skills required to use these assistive technologies are the most important criteria for day-to-day use and adoption. So as a part of the development process, we did an initial market gap analysis, which shows existing tools and hardware solutions like wearable technology and smart canes to be priced between $4,000 and $10,000. So just because like price was something we were trying to bring down for our option, it doesn't mean that it's not important to look into those technologies that are advanced. Maybe we could look at some of the features that have hardware solutions and incorporate them somehow into our free mobile version. And after that, we found other applications that were free of cost and had, limitations to their features. So a quick analysis of these two products, Seeing AI and Envision AI. Seeing AI offers real-time face detection, but only if the person is directly looking at the camera. So if I was looking somewhere else in a different direction and someone pointed the camera at me, Seeing AI just wouldn't detect me as a real person unless I look at it. So it can sometimes determine the relative location in a frame, but it's off. Then there's audio description of an image, which is good. We should try and incorporate that into our application. Then Envision AI. It's also somewhat slow in real-time object detection. And then the other drawback of this application is that it only provides text descriptions of images. There's no audio. So here we can see my team member from the AI4GoodLab was looking directly at the camera, and the Seeing AI just wouldn't detect her. It says no people could be detected. So it's not very user-friendly. And although it claims to provide real-time face detection. Then Envision AI, it's quite slow. There isn't even a chair in this image, and it's telling us there's a chair. And it lacks navigational directions. And again, it's not very user-friendly. So finally, we decided the spot we wanted to fill is the one in the top left right here. So it's the one that's free and provides a large amount of features. These features support real-time user interaction, video input support, audio description generation, and clear path navigation. Here's a brief overview of our model. We'll go more in depth in just a moment with some demos, but essentially we have YOLO World for object detection, Mira for depth estimation, and our algorithm includes object localization, relative distance calculation, and real-time clear path navigation. So in this video, I'm going to play the video in a second, but let's ignore the gradient of the colors, just ignore all these colors here and focus on these boxes that are identifying objects in the video. There's a chair on the left and right. We have a person in the middle. Amazing. So when we focus on just that part, what we see is the YOLO World model in action. YOLO World is a pre-built machine learning model that stands for You Only Look Once, YOLO World. And you can think of it as like a super fast detective that looks at a picture and instantly finds everything important in it. Imagine you're looking at a super messy room and you're trying to find your backpack, your phone, your shoes, and instead of scanning every single inch of your room to figure out where it is, with just one glance, it instantly recognizes where these things are. And that's exactly what YOLO does with images. It finds objects really fast with just one look. It gets an image as an input, then kind of like a chessboard, it divides that image into a grid. Then it checks all the sections of this grid and identifies where the objects are. It puts boxes around these objects and put labels over them. The YOLO World model is really special because it's super fast. With just one look, it can tell you where everything is. And, it can detect many objects at once. That's the other important part. It's not just you take a picture and it's like, find me one thing from this. It's going to, with this image and the last image, video that we saw, it found everything in the image. It found the person that was there, the chair on the right, the chair on the left, any object that was in that video, it found. Some examples of YOLO world in real life are in self-driving cars, where it identifies people or traffic lights, as well as other cars around that car. Surveillance cameras use YOLO world as well, with finding people in security footage, or robots in warehouses to detect packages. Why did we use pre-built models like YOLO world? Instead of building a computer vision system from scratch, we can use models like YOLO that are already trained on millions of images. So this saved us a lot of time. It's kind of like using a calculator instead of doing math by hand. Because without this model, my team and I would have had to go around and take pictures, millions of pictures of every, like, of street lights and chairs and all sorts of things, and build a whole database to train our model. So since YOLO World was already, this model was already pre-built, we use this for our context. And then next we'll rewatch the same video again and try to pay attention to the color gradient this time and the information that it's telling us. So I'll just quickly play that video again. Okay, so in that video, we just observed the MIDAS model in action. So the MIDAS model, it stands for monocular depth estimation. So what is it exactly? Imagine taking a photo with your phone. The picture is going to look flat because it's two-dimensional. When you look at the world around you with your own eyes, you can tell which objects are closer, which ones are further away, and that's called depth perception. And MIDAS is a special AI model that looks at a single 2D image and figures out how far away different objects are, even though it only has one picture to work with. And so how exactly does that work? So MIDAS gets an image as an input. It looks at things like shadows, object sizes, and perspective. And it colors the image so the objects closer look super bright. So in the image previous, like in the video we saw earlier, it was red and yellow were for things getting closer to us, and then further away would be blue and purple, so the cooler colors. And it's super cool because it works with just one image as well. Why did we use MIDAS? So instead of needing expensive 3D cameras or LiDAR like self-driving cars use, MIDAS lets us use regular cameras to provide information about depth perception. So as a whole, our system accurately detects objects in the scene and is fast enough to work in real time. The back end of our algorithm takes the video input in each frame, and it determines whether objects are in the left, right, or middle. Then using depth map, we calculate the proximity of an object to the person. And to ensure the user's privacy, we also don't store the video inputs. And the novelty of our algorithm lies in how we use this information in each frame to identify clear paths and propose navigation. So at the top of this video, I'll play it in just a second. You can see how sitemap proposes navigation with a green arrow. So this is what we process in the backend, and this is what the user will see. But we can provide both, both interfaces.
Table on the left, table on the right. Move straight ahead. Table in the middle, chair on the right, move left.
Sitemap also provides explainability for transparency and educational purposes to inform users about how our system actually makes decisions. So instead of like a system that just shows this video on the top where it's just proposing turn right or turn left, when you see this heat map with the bounding boxes that say that these are the tables, this is how close it is, how far you are from these tables, it actually explains why is it proposing you to walk straight? Well, because there's something on the left and the right. So it's telling you to walk in the one direction, that there isn't an object intruding. Another important reason that we decided to develop this iteratively using object identification and then depth map, and why we layered these two models on top of each other, is because firstly, like when you're navigating, we decided, okay, well, it's important to know their objects. But then object identification isn't the be all end all, because some of the actual existing applications we saw. And, you know, when we put ourselves in the shoes of the users, we realized knowing that something is far off in the distance, as well as like close to me and then further away, like since YOLO World will just give me all the objects that it sees in an image, I could be told in any order. So order matters. The priority that I receive this information is crucial, because I don't want to know what's furthest away from me first. I need to start with what am I closest to? Because if I'm concerned about finding a place or my safety, we need to first identify what's closer to us and further away. So that's why then we decided to layer the pre-built model with the Miras, and with both of these working together, and then putting the clear path navigation model on top, we were able to build our final whole product. So here are some of the pictures of the participants in the lab across Edmonton, Montreal, and Toronto. On the right is a picture of my team. We actually won the Accelerator Award after pitching our project. And my 3 teammates for this project were Sevi, Destiny, and Zara. To end off, I would like to just share some words to inspire you to work towards making meaningful social change with technology. Firstly, understand the problem from individuals directly connected to the challenge. Sometimes what we think the problem is isn't what the problem actually is. So it's really important that although we were inspired that, oh, we should try and solve this gap for social change for people dealing with visual impairments, to actually go to the root, put a genuine effort into trying to do that. So you actually build something with towards like meaning. And to develop in iterations, like you don't need to build like the whole full layered product all at once. We identified one problem at a time, and next we prioritized those features, and based on that prioritization and developing in iterations, we were able to achieve a full functioning proof of concept at the end of our project. And then also it's to refer back to the goals set by the team. So yes, the goal was to build for social good and make meaningful change, but also normal goals like, oh, I want to try something new and learn this. I want to learn more about computer vision. I would like to practice my presentation skills. I want to learn more about visual impairments. All those types of things are valid goals that are set by the team. So even if we didn't win, this was our mindset going into this project, that we have set goals at the start of the project of what we would like to achieve at the end of this program. And we're going to work each day towards getting that goal. So regardless of whether or not we won the Accelerator award or not, I think we all grew and challenged ourselves to grow in different areas throughout this project, working together. And lastly, don't be afraid to try something new. So yeah, this is a little slide to cover the lessons that I learned that I just shared on the previous slide. And thank you so much for having me today. That was all for my presentation.
Wow, Mira, that was incredible. You did such a good job of explaining the process of innovation. I can't thank you enough for really helping us understand what it means to solve a problem, and then how you thought about AI and that innovation can be from things that exist already and used in new ways in order to solve a problem. I know you have to scoot off to your next class. Do you have time for one question or 2 questions?
Yes, I can definitely answer 1 or 2 questions. Thank you.
Okay. So, um, what's happened to this project since? So you did that in the summer a while ago. Like, where is this now, and where are you now?
So after we did this project, we got the Accelerator Award, and that entailed getting more mentorship and guidance to build this into a scalable startup company. And so our team was very diverse. We were very fortunate to have team members across different parts of their career. So we had a grad student, we had someone already working in industry for her first year, a second year undergrad, and then myself ended like in my final year of university. So since people were at all these different timelines, we committed for 2 extra months in the summer to take these sessions that the Alberta Machine Intelligence Institute and the AI4GoodLab provided us to learn more about startup companies, proof of concepts for those, how we would actually build this up. And after discussing that, we realized at the very start of this project, we wanted this to be a free solution and not put a price on it. So we didn't really think of this being a profitable project from day one. So we were really struggling with the idea of how should we turn this into a startup instead of something like a nonprofit, or working in collaboration with a nonprofit to develop this program. And then so we did like think critically about that. And but then after school started, I guess everyone just like went off like, pursuing their own things. So then we didn't really get too far ahead. And that's why I really say in the end that it is a valid goal to just say, I wanted to come to this to learn something. I wanted to challenge myself to critically assess that, we have considered societal impacts. We haven't just said something for the claim that, oh, we're going to make this for social good, and then just throw a buzzword and they're like, oh, we're going to help a visually impaired individuals. We actually talk to the CNIB, and all of those, that entire process was something to learn. And I'm sure we can reapply that into, our future projects that we'll work on. And like, I'm here today sharing this, so I'm sure you guys will take that advice and also bring that to life. So.
Okay, and just my other question is, how did you get to be a part of the AI4GoodLab? How does that happen?
Yes, so that's a really good question. So for the AI4GoodLab, I was involved in undergraduate research at the University of Alberta, and the professor that I was working under, she actually recommended that I look into this lab, and she's like, you seem like you might want to get more hands-on with this. And and I was in my second year of university at the time, so I thought, she said, since you're not at the advanced like classes yet, which you get to in your third year, fourth year, or fifth year of university, she said, you know what, this is a great summer opportunity to really get your foot through the door with AI and just get building something. I think when you try and get your hands dirty and try and build a project before diving into the theory of what's exactly going on, because in this lab, like, we use pre-built models. It's not like we were on the forefront of research and scientific development. It was just like playing around, getting used to the technology, getting comfortable, like thinking about where can I apply this, expressing ourselves and like our passion for technology and creativity. And I think that was exactly where I was at in my second year of university. So when she recommended I look into this lab, I applied right away, and I didn't get in the first year, so I applied again the next year, and then I eventually got in. So yeah, that was my process of joining the lab.
Oh my goodness. Yay to the adults in the world who notice things and point people in directions and connect them to opportunities.
Yes.
Wow, really wonderful. Mira, I know you have to go, so I do want to thank you so much. I have learned a ton today. I know my students will have learned, the students in the challenge will have learned a ton, and the teachers as well. And most of all, be inspired by what you did to maybe themselves become creators with artificial intelligence. So thank you for joining us. We really appreciate your time today.
Thank you so much. Bye, everyone.
Amazing. It just always takes that extra second.